Let us try to solve some numerical problems on RMS and the average value. This is the first question. From the figure, we have to find out the RMS value of the alternating current. We know that RMS current is given as IRMS, which is equal to I1 square plus I2 square plus so on up to IN square whole divided by number of intervals divided by 2. In this case, in the peak we are having three values of the peak alternating current. One over here I1, second is I2, third is I3. So I1 is plus 2 ampere, I2 is minus 2 ampere, I3 is again plus 2 ampere. So if we apply for these only I1, I2 and I3, IRMS will be equal to I1 square plus I2 square plus I3 square whole under the root divided by n, which is 3 currents, so divide by 3. So it will be equal to 2 square plus minus 2 square plus 2 square divided by 3 under the root, which will be equal to 4 plus 4 plus 4 divided by 3, 12 divided by 3, 3 4s are 12, 4 under the root, which is equal to 2 ampere. This is our first answer. Second question, if the effective value of the alternating current is in 50 Hz AC is 5 ampere, find the peak value of the current, mean value of the current over half cycle, and the value of the current 1 over 300 seconds after it was 0. Solution. First part, we are given the RMS value. RMS value of the current is given 5 ampere and frequency of the AC cycle is equal to 50 Hz. We have to find first peak value. We know that IRMS is equal to I naught over under root 2. This means that peak value I naught will be under root 2 times RMS, which is 1.414 into 5, which gives us answer 7.07 ampere. Second part, we had to find the average value over half cycle also. We know that average value or mean value is 2 over pi into I naught, which is 2 over pi is 0.637 into peak value we have already found 7.07, which give us the answer 4.5 ampere. Third part, we have to find out the current 1 by 300 seconds after it was 0. So if we take a look at the AC cycle looks like this. So you can see that AC current is 0 at this point O. This is the time, this is the current. So this is the time at which current is 0. So after 1 by 300 seconds after, suppose at this point the time is from O to this point, say A is 1 over 300 seconds. So in this time interval we have to find what's the value of the current. We know that I is given by I is equal to I naught sin omega t, which we can also write as I naught sin 2 pi f into t, because omega is equal to 2 pi into frequency. So it will be 0.707 multiplied by sine of 2 pi, frequency is 50, time is given to us, which is 1 over 300. So it is 56 300, 2 3s are 6, we are getting 0.707 into sine of pi by 3, which is equal to 0.707 into root 3 by 2, which is after calculation gives us answer 6.12 ampere. Third question, an alternating voltage is given by V equal to 140 into sine 3 140 which is connected across a pure resistor of 50 ohm. We have to find the frequency of the source and RMS current through the resistor. V is equal to 140 into sine of 314 into T. If we compare this equation with V is equal to V naught sine of omega t. So if we compare the two equations, peak value of the voltage comes out to be equal to 140 volt and the frequency is equal to omega is equal to 314 radian per second. In this case, omega is equal to 2 pi f, which is equal to 314, or f will be equal to 314 divided by 2 pi, which is 314 over 2 into 3.14, which is 100 by 2, which is equal to 50 Hertz. So this is our answer. Now we want to find the RMS current through the resistor. We know that the relation between RMS value of voltage and its peak value is Vrms is equal to V naught over root 2, which is equal to 0.707 into 140, which on multiplication gives us 98.98 volt. So the RMS current through the resistor of 50 ohm will be Vrms over R, which is 98.98 over 50, which will give us final answer 1.979 or 1.98 ampere. Our last question. The peak value of alternating current of frequency 50 Hz is 14.14 ampere. Find its RMS value. How much time will the current take in reaching from 0 to the maximum value? So in this case, RMS value is given to us. RMS value is 14.14 ampere. From here we can get the peak value. Sorry, the peak value is given. This is not the RMS, it is the peak value, which is I naught. So we can get I RMS from here, which is equal to I naught over root 2, which is 14.14 over 1.414, which is 10 ampere. This is our first answer. Second question is, how much time will the current take to reach from 0 to the maximum value? Now frequency of AC cycle is given 50 Hz. So if we find out the time period of this AC cycle, it will be 1 by 50 seconds. So if we take a look at the AC cycle, in this AC cycle, this is time 0, this is T by 2, this is T. So over here at this particular time, the AC current becomes maximum. So we had to find out this current. If we take a look at this full AC cycle, we can divide this AC cycle into 4 equal parts. So here current time is 0, here it will be T by 4, it is T by 2, here it is equal to 3T by 4. So we see that after T by 4 time the current reaches its maximum value. Therefore, time at which current is maximum, it will be equal to T by 4, which will be equal to 1 over 4 into 50, which is 1 over 200 seconds. So you can also divide the result. You will get 0.005 second, which is 5 milliseconds. So after 5 milliseconds from 0 time, the current will become maximum. Thank you.